Good afternoon all. I think it's time for another power bank video. So I have here a couple of Poundland power banks, or they may be Pound World. I honestly can't remember. Don't think it matters that much. And I've been playing around with these things, charging them up. You get a nice flashing red light when they charge. Also, these cables get quite warm. They must be very, very thin inside. Now, we know that these things are a bit rubbish, don't we? I mean, it says on the end there, output DC 5 volts, 800 milliamps max. And that's despite the packaging saying 1200 milliamp hours, 1 amp. There's no way these things are 1200 milliamp hours either. Should we take a quick look inside one of these? Although that's not really the purpose of this video. So there it is, a little circuit board with the two USB sockets, the input and the output socket, and an 18650 of dubious origin. So let's unplug this charge cable, and the flashing red light turns to a steady blue light to indicate that this thing is putting out power. It's now detected there's no load, so it's shut that power off. Let's see if we can get all the gubbins out. So that's the cell partially removed. Now I think if I pull hard on that... No, oh yeah, that's come out, and that's all it is. It's just an 18650 cell, some of these metal strips soldered onto the board, and let's take a closer look at that PCB. Well, not a lot. On the top we've got the USB output socket and two light emitting diodes, the red one which flashes when you're charging it, and oh, I thought that the blue one would come on then, but anyway, the blue one which comes on when this thing is providing power and flashes when the battery's getting a bit low. And on the top side there's the input USB socket. There's a little 8-pin chip and an inductor and some resistors and capacitors. Let's have a look at the chip, and it is either an FM9833E or it's a CG8MOQ18. I think it's the FM9833E. Okay, Shenzhen Fuman Electronics Co. FM9833. It's in Chinese, but it says MOSFET DW01, 90%, 5 volts, 1 amp, SOP 8 and 4.2 volts, 4.35. And here are a couple of application circuits with an input USB micro socket, 5-pin, an output USB standard type A socket. Oh, look, D plus and D minus are connected together. Have as much current as you like. There's the battery, 18650, and two LEDs. But it's not really the internals of this power bank that's got me quite excited. It's the operation of the thing. It's the way it behaves. You see, when you charge it, you get this red flashing light, and the output is actually disabled. Well, it's not quite disabled because this little plug-in USB light thing is slightly lit up, but not lit up very much, so I'm suspecting that the boost converter has been shut off, and this is just getting 3.7 or perhaps a bit more than that, 4 volts directly from the cell. What's interesting is when you stop charging it, if I pull out this micro USB charge cable, the microcontroller, or really that purpose-made chip, says, I'm not being charged anymore, now I'm going to turn on my output. And on it goes at 5 volts, and the blue LED comes on. And it's that automatic switchover from being charged and switching the output off to not being charged and switching the output on that gave me an idea. And that is to charge one of these power banks from the other one. So the purple one, actually it's pink. The pink one is providing power, and I'm using it to charge the green one. Now what if I add the other cable? So now I'm going to connect the output of the one that's being charged, which will only have this 3 point something volts on it, to the input of the one that's doing the charging, if I can get that to fit in there. And, well, nothing actually changes because the output of this one, because it's being charged, is essentially switched off. However, if I stop charging it by pulling this plug out, it switches over. This one now turns its output on and is charging the pink one. So let's plug that back in. Nothing happens. Let's pull this plug out. And they swap over again. Now the pink one is charging the green one. So what we've actually got here, that shouldn't have happened, but never mind. What we've actually got here is a bistable. Pull this out and it flips over. Let's call that a 1 because it's doing the charging, and call that a 0 because it's being charged. Plug that in, pull this one out, and now we get 1, 0. Plug that back in, pull this one out, and now we get 0, 1. This is a bistable latch. So I'm thinking this could be a whole new type of logic, the Poundland Powerbank Logic. And we have here a flip-flop. Now this one is starting to get weak. It will carry on charging the green one for a while, but when it finally gives up and says I have no more energy left, it'll actually shut off. And then guess what happens? This one, because it stops receiving charge, will go blue and start passing charge back the other way. So not is it only a bistable if I pull these plugs out, it's also an astable because the switching over happens automatically. So what I'm going to do now is wait for this to get completely exhausted, and for that switch over to occur, I'll chop out the boring bits where I'm sitting here just yabbering. Let's wait till that happens. There goes the switch over. This power bank is completely depleted, so it switches off its output. That green one then detects that it's no longer being charged, so it switches on its output, and now it's charging the pink one. But how long can the green one last before it starts saying, oh, I've got no energy left, flashes its blue light, and then eventually switches off? Well, let's see. Right, the green one has now started flashing its blue LED, saying I'm a bit low on power. I'm actually going to give up shortly. And when it does, it'll switch its output off. And then the pink one will no longer be charging. Let's see what happens. There goes the green one. It's out of juice. It's switched off its output. The pink one responds by saying, I'm no longer being charged. I'm going to switch on my output. And it, in turn, is charging the green one. So these power banks are not only a bistable, a bistable latch, a set reset latch if you pull the cables out, but it's actually a very slow oscillating astable multivibrator. Brilliant. Now what if we add more power banks? So I've been down to the pound shop and got the yellow one because I think it fits nicely with these colours. Let's see if we can make a ring oscillator. I'll just get rid of this rather naff keyring strap thing, which we don't want. So that can come off. Right, so what I've got to do is remove that and put that in the yellow one, and then link the yellow one input, which is there. Oh, that's a bit of a tight fit, which I think I'll put that input connector in first. These are not very nice USB sockets. Try and jam that in, and then put that into there. Three-way ring oscillator. What does it do? Well, we're about to find out because the pink one has started flashing its blue LED, so it doesn't have a lot of charge. Now when that switches off, the yellow one will stop charging and will start providing power, and that should start charging the green one, shouldn't it? Let's see. Right, so now the yellow one is on and charging the green one. Now the yellow one is brand new, so that's probably got quite a bit of juice in it. So that could run for some time, but when that does eventually give up, that should switch off. And then the green one, having received a bit of charge, will switch its output on and start charging the pink one. It's fantastic. And just in case this isn't enough power banks, I thought I'd extend the concept with 3 more power banks in the other 3 colours. There are only 6 colours, white, black and dark blue, or is it purple? So is this a new family of logic? Poundland Powerbank Logic. We've built the bistable, we've built the astable multivibrator, and we've built the ring oscillator. Or is it just a shit idea? Let me know in the comments. Cheerio.